Okay, so the next part we're going to review is 5.3 and 5.4 together because all of the rules for graphing apply to both functions. 5.3 was the square root function. Square root function looks like this. When we start the square root function, we want to pick easy points to plot. Easy numbers to take the square root of. 0, 1, and 4. 0, 1, and 2. Right? When we do the cube root function, we want to pick easy numbers to take the cube root of. So you can use 5 numbers if you want. It gives you a better shape, but we're just going to use 3. Okay, so these are easy numbers to take the cube root of. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. So what do these look like on a graph? Okay, square root function. 0, 0, 1, 1, 4, 2. Okay, it looks like this. This is the initial point, right? This is the initial point. It stops here. This is continuing forever in this direction. So our domain is our x values. Our domain is starting at an x of 0 and going forever to the right. So that is that is positive infinity. Our range on the y's starts at 0 and it goes up, so it goes to positive infinity. For our cube root function, our cube root has these 3 points. I don't just connect them in a line. Our cube root function is curved. It curves this way and it curves this way. This is an inflection point. That's where it turns. Okay, so it's like a curve that goes like this, and then it turns and curves the other way. The domain and the range for cube root is all real numbers. So negative infinity to positive infinity for both. It's continuing to the left and down forever, and it's continuing to the right and up forever. Those are our parent functions. Now, when we talk about our transformations, you can use whatever letters you want. The big thing to remember is that if it's inside the function, it's impacting the x's, and if it's outside the function, it's impacting the y values. So what do I mean by that? If this is my square root function, stuff that happens on the outside, if I have a negative out here, or if I have a number out here, okay, those are things that are impacting my y values. If I have a plus or minus some number on the outside here, that impacts my y values. Okay. When I have stuff on the inside of the function, I'm going to use a b value, and I'm going to put this in parentheses. I didn't really leave much space. Oh my gosh, I'm going to rewrite this whole thing because it looks crazy. Okay, so ignore that. This is better. Okay, it's either a positive or negative coefficient out here, either a positive or negative coefficient inside. We're either adding or subtracting something from my x value, and we're either adding or subtracting something on the outside. These are rules we've been talking about all year. This sign out here, if it is negative, it reflects over the x-axis. Okay? The a value determines a vertical stretch or a vertical shrink. Okay, it is a vertical stretch when that a value is a number that is bigger than 1. So like 2, 4, 8, whatever, something bigger than 1. It's a vertical shrink when that number falls between 0 and 1. So like 1/2, 2/5, stuff like that. Okay, the sign we're not paying attention to. Okay, the sign is for the reflection. If it's a negative, That's the reflection part. The A is separate from that sign. Okay. Inside is a different reflection. If it is negative, it reflects, but this time it's over the y-axis. Okay, the B value, which you might have called it a different letter, it doesn't matter what letter you call it, the B value is a horizontal stretch or a horizontal shrink. And this is a little bit confusing because it's backwards. Okay, stretch is like numbers bigger than 1, so our big numbers stretch it. Well, this is opposite. Okay, these have a horizontal stretch when it's a number between 0 and 1, and then it's a horizontal shrink when our number is greater than 1. And I should have wrote a B there. Okay, in your books, there is a good chart with examples in section 5.3. So if you guys look at, hold on, I'm finding the page number. If you guys look at page 442, okay, page 442, there's a nice chart that gives you some examples on that page. Okay, 442 is a nice chart. Alright, I need another color because this is looking messy. Inside here, the plus H, if it says plus H, this goes to the left. If it says minus H, it goes to the right. If it says plus K, it goes up. And if it says minus K, it goes down. Those are things we've done all year. All year we've been doing this one. All year we've been doing this one. All year we've been doing these. This B and the positive or negative inside, that's the new thing. Okay? When you have a function, so let's say we have lots of stuff going on. Okay? This is a reflection over x, a vertical stretch of 3. A reflection over y, a horizontal shrink by 4, but you do the opposite on the inside, right? So when you talk about the horizontal stretch and shrink, you have to also take the reciprocal. So when we say this is a horizontal shrink, it's by 1/4 because it's a reciprocal of that. Okay, and then we have a left 1 and a down 5. Okay, so reflect over x, or a vertical stretch, reflect over y, horizontal shrink, and it's by 1/4. This is left 1, down 5. Okay. So that's the general rule. Okay, we're not going to do all the problems from 5.3 on the review. We're going to do the one that has a lot of steps to it. So we're going to look at number 23. Okay, number 23 on the review. Because if you can do this one, there's 3 steps to this. You can definitely do the other ones. Okay, we've got 0, 1, 4, 0, 1, 2. I just started out with easy numbers, right? This 3 on the outside is a vertical stretch. Stuff on the outside impacts my y values. So I'm going to multiply my y values by 3. Okay, this minus 4 is on the inside. Inside the function impacts my x. This means move right 4. If I move right 4, I'm adding 4. Remember, inside you do the opposite. So add 4, add 4, add 4. Okay, then outside is a +1. Outside affects the y. So add 1. 1, 4, 7. These are the points that I'm going to plot. I need to plot 4, 5, and 8 on my x-axis and 1, 4, and 7 on my y. So I'm in quadrant 1 for this. So when I use this little graph here, I'm going to make my x and y axis here. And if I count 1, 2, 3, 4, 5, 6, 7, 8, I can fit what I need on this graph. Okay, and 1, 2, 3, 4, 5, 6, 7, I can fit what I need on this graph. So this is 8, and 1, 2, 3, 4, 5, 6, 7, and this was 8. So I need to show what I'm counting by, and I need to clearly plot my points. So 1, 2, 3, 4, 1. Okay, 5, 4, 5, 1, 2, 3, 4, and 8, 7. So all the way up here. So this graph goes like this. Okay, if I want to state my domain, I'm looking for my smallest x value. I go to my initial point. Okay, this is my smallest x value. It's a 4. It's going to the right, so it's going to infinity. My range, I look for my smallest y value. It's right here. So my smallest y value is 1, and it's going up, so it's going to infinity. Okay. Alright, we're going to look at 5, 4. We're going to look at number 35, because 35 has a lot going on. Okay, and like I said, if we can do 35, we can do all of them. Alright, so 35, x, y, it's a cubed root. So we do -1, 0, 1. Okay, on the outside, I've got a negative that's impacting my y's. So I'm changing these signs. I've got a vertical stretch. Vertical stretch by 3, I multiply all of these values by 3. It's on the outside, so it's the y's. Inside, it says +2. +2 means I'm moving left 2. If I go to the left on the graph, I'm going to have to subtract 2. So subtract 2, subtract 2, subtract 2. -1 is on the outside, so it impacts our y's, and it's moving down. So down 1 means I take 1 away. Down 1, down 1, down 1. These are the coordinates I'm plotting. I need -3, -2, and -1 on the x, and I need +2, -1, and -4 on the y. So I'm going to make my graph with my x and y like this, because I need mostly quadrant 2 and 3 on my graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I want to label what I'm counting by. I go -3 and up 2, -2, -1, and -1, -4. Okay, this is a cube root graph, so I'm going to make sure I show my curve. It's not a straight line. Okay, my domain and range are going to be all reals, okay, because it's pointing up and left and down and right. All reals for both domain and range. And you can see this inflection point moved. It moved left 2, down 1. Right, that's what I did, left 2, down 1. Okay, I want to talk about number 36. It says, let the graph of G be a reflection in the y-axis. So y-axis tells me I have a negative on the inside, followed by a translation, 7 units right. So 7 units right means I'm going to be subtracting 7. Because remember, when it's to the right, it's a minus. Okay, the important thing here is that you put those parentheses because this reflection is separate. It's out in front of this x minus 7. Okay, it's important you keep that outside there. Alright, one other thing I want to make sure we talk about. If you have a function, let's say that this is a cubed root, and we have 2x plus 6 inside here. Before I decide my left and my right and my stretch and all that stuff, I want to make sure I factor out this coefficient. What I mean by that is that 2 needs to be out in front of the parentheses. So when I pull that 2 out, I'm also pulling 2 out of this. So it's a 2x plus 3. So this is going to be a horizontal, and this number is, we need the reciprocal of it, right? So when I do the horizontal shrink, it's a horizontal shrink by 1/2. And then this is a this is a left 3, because it's a plus, a left 3. If I had a negative number underneath there, and let's say I had something like this, I have to take that negative and factor it out. Okay, that's a horizontal change, so it's reflected over the y, and then this is going to be moved right 1. Okay, if I don't factor it out, I'm going to screw up my left and right stuff. Okay, so anytime x has a coefficient, whether it's a number or just a negative sign, you got to factor that out. Okay, so that's the review for 5.3 and 5.4.